Hello! Today we are gonna go for a video that it's not gonna be part of any series, well, I think at least, but it's just something that I do as an exercise. I'm still trying to figure out a way to develop an engaging style, an engaging, especially voice style, which is not too boring, but still clear enough. So here we go with this exercise where I'll talk to you about JavaScript functions, a very crucial topic for beginner programmers. But in my style, I don't like to start proposing immediately a solution. I prefer to discuss first the problem. And in a typical course, we would already be familiar with the usage of variables, taking decision using conditionals, iterating with loops, and probably we would be acquainted with our first data structures, arrays. And with these tools, we can already accomplish quite a lot. But as soon as we go beyond the realm of very specialized programs or very small programs, then we are going to hit a wall. And the wall that I'm talking about is that we are still unable to repeat complex logic. And with repeat, I don't mean like repeat a simple action over and over like in a for loop. What I mean is that we have developed, or someone else has developed, a very interesting block of logic that it's common and so that we have to reuse. Sometimes we want to reuse it as is, sometimes we want to reuse it, say, on different data. And yes, we could try to solve this problem with simple copy and paste, but that would be a terrible idea because we always want our code to be dry, where dry means don't repeat yourself. And actually, I think if you think about it, you can probably figure out by yourself a few reasons why copy and pasting, it's an immediate solution, but then it turns out to be a huge mispractice, a huge bad practice. So can you guys figure out why it is so bad? Well, the thing is, it's not so bad in the moment where you do it, but the real problem come out when you have to modify that logic, when you have to make changes to that logic that you've copied and pasted pretty much everywhere. And this is a problem that's way worse than just the bloating of code, because now you have to go and hunt around in all the places where you think you copied the code and make the same modification over and over. And as you can imagine, this is a very error-prone process, beyond being, of course, extremely boring. It's just a sure way to introduce bugs in our program. So please remember, even if you're now just an aspiring software developer, we developers are never satisfied just with a program that simply works. We want a program can be sure we can evolve, that we can maintain, that we can change, because as a software developer, you'll spend most of your time not playing around with writing code from scratch, but actually maintaining and evolving existing code. So finally, time for the solution. The basic solution for code reuse in programming is using functions. Because functions are just blocks of code with a name, basically. And to introduce them, we can actually make a comparison with something that we already know, like variables. And for example, here you see that I create a variable x and I initialize it with an expression that is the simple integer literal 3. It's a data item. And now that I have the variable, I can play around with this data item all along my program. On a similar note, you can see that I can define another variable greet where that I initialize not with a simple value, but with an expression that has as a result the creation of a function. And so it's called a function expression. So this variable actually will point to a function. And the syntax, as you see, is quite simple. You have the keyword function followed by parentheses. and then a code block. We are already familiar with code blocks because this is the same concept that we met with conditional and for loops. So you already know that basically this curly bracket means here starts the code of the function, and this final curly brace is there to say here ends the code of the function. In JavaScript, actually, we always had, from the beginning of the language, we had two ways of creating function. The function expression that we just discussed, and the function declaration, where you see the syntax and the logic is a bit different. We don't declare any variable. We just use the keyword function. Then since we don't have the variables, we express the name of the function, greet, then the parentheses, and then our code block. So you actually have to be familiar with both of these syntax because they're both equally used. And actually, we'll finish this lesson talking about a third syntax that has been introduced as later on arrow function. But for now, just absorb, get familiar these two syntaxes for creating function expression and function declaration. So, what do you think will happen if we execute the code that you see in this slide? Well, actually nothing, because what we have done so far is just to let JavaScript know that the function greet exists, but we never asked for it to be called or executed or invoked. Those are all legitimate ways to express this concept. So to execute that logic and actually see our greeting, we have to invoke the function. And invoking a function is extremely simple. You just write the name of the function, as you see here, followed by the parentheses. And in fact, whenever you will see a name followed by parentheses, that means that you're looking at a function invocation. So, what is the role of the parentheses? Well, if you remember, we thought one of our objectives was that we wanted to be able to re-execute logic, but in the context of different data. So how can the function act on that different data? Well, we can pass the data to the function as input parameters. As you can see here in this function expression, the function expects two input parameters, x and y, and then it prints that the sum of x and y is the value of the sum. And as you can see, since now the function expects two input parameters, when I invoke it, I have to give the values for these two input parameters. And here you can see that sometimes I just pass integer numbers like 2 and 4 or 4 and 2, and sometimes I can pass variables that has been previously initialized. So what do you think the output of this snippet will be? As you can see, I'm declaring two variables, x1 and x2, and then I'm writing a function that takes in input two input parameters, x1 and x2, and what it does is that it switches their values, it swaps their values. So it puts the value of x2 in x1 and the value of x1 in x2. This is a very classic little algorithm. And here, I invoke the function swap, passing my two variables x1 and x2. So my question is, now that I go and print the values of x1 and x2, what will I see? Will I see the original value, 0 and 1, or the swap value, because I swapped the values calling the swap function? So what do you think? Well, actually, the values will be the original one, 0 and 1, and they won't result as swapped. And the reason for that is that you have to understand that what gets passed here when I invoke the function, and there's a name for these two guys. These are called the arguments of the invocation of the function, and they are my two variables x1 and x2 are passed as arguments to the invocation of the function. They are not the same things as the input parameter of the functions. These two input parameters are two different variables that are initialized with the value of the arguments that the function uses in its invocation. So basically this parameter x1 is initialized with the value of the argument x1, and the parameter x2 gets initialized with the value of the argument x2. Some people also say that the arguments are passed by copy, so basically the input parameters are copies of these two guys here that are the arguments of the invocation. So now if you understand this, you understand that I can do whatever I want to these two input parameters x1 and x2, but this won't change the value of the variables that I use as arguments. And this is by design. This is because I don't want that if I pass my variables to a function, then after the function is done, the variables that I gently pass to the function as input parameters, now they are completely changed, they are completely screwed up. No, I don't want that. And that's why the invocation of the function does this pass by copy. Now, I just want you to show a little detail. This is nothing earth-shaking, but a nice thing about JavaScript is that you can have parameters with a default value. So let's say that we have this function apply taxes, and the inner working of the function depends on this boolean that you passed. That means that the subject that we are working with has some tax privileges, and most of the time this will be false. So I can say that this parameter has a false value. What does it mean? It means that when I invoke the function, if I don't pass the value for this second parameter, then the second parameter will automatically have the value false. As you can see here, the first time I invoke the function, let's say regularly, passing both parameters, and the second time I invoke it passing just the first, confident that there will be no error, and then the second parameter won't be undefined, but it will have the value false. Another interesting technique that I want you to get familiar from the start is this of the rest parameters. These are called also varargs in other languages. Here, for example, I want a function that is doing a report for some student, and I have to pass the first name, the last name, which get always printed, and then I have to pass the list of grades, but I want the freedom to pass 0 grades or an arbitrary number of grades. Yes, I could pass an array, but then I would have the caller of this function would have to assemble this array, and this could be quite inconvenient. Instead, with the syntax of the rest parameter, you see ... grades, what happens is that inside the function I can look at this as an array. I can count on having a grades array that will be empty if when I invoke the function I don't pass any grades, and that will contain instead all the variables that I passed after the first name and the last name, so that I can actually make, for example, a for loop on the grades and print stuff about them. Notice also here that once I know that I have some grades, I also go and call this other average function, which is another function that I created to calculate the average of the grades. And I'm doing this just to show you that it's perfectly normal that a function that we create, while it's executing, makes a call to another function that we created or that someone else created, an API function. There's no problem about it. I just want you to get very familiar with it. And another little nuance of this is that, as you can see here, calling the function and then I'm calling toFix on the result of the function. So I'm not creating an intermediate variable. I'm just saying, let's invoke the function that calculate the average grades, and on that we call toFix. But well, this is kind of an advanced technique, so you'll understand better after we discuss the return statement actually. And so as you can see here, when I invoke the function, I invoke it sometimes with grades and sometimes just with a first name and last name for this lazy skippy skipper. And for completeness, this is just the code of our average function. Here you find a guard function just to make sure that the elements that the array of grades is there, and it has a dimension that greater than 0, and then once that I'm sure that these prerequisites are met, I just go on and cycle over the elements, calculate their sum, and divide for the number of elements, which is the definition of the average. Well, after we discussed input parameters, there's another crucial concept that we have to master, and that is the return of a function, because just as a function takes input parameters, it can have output. And with output here, I don't mean writing to the console, I mean returning a value to its caller. As you can see here, I invoke this function sum, which takes the two input parameters n1 and n2, and this function returns the sum, an expression that has as a result the sum of the two integers, of the two numbers. And so when I call sum, you can imagine that the function executes, and in its place it materializes what the function returns, what the function promised to return after the keyword return. And so the value of the sum is what is assigned to this variable s. The variable s is initialized with what? With the return value of the function sum, with what the function sum returns after its invocation. And how many things can I return from a function? Well, I can return just one thing. Well, it can be a complex thing, like an array or an object, but you can return only one thing. Does that mean that you must have only one return statement in your function? No, you can have more than one. Like in this example, where I have a function that receives an array and a value and cycles through the array, and as soon as it finds one of the elements of the array which has the value equals to what we are looking for, it returns its position. So it can return at different times, or if it doesn't find anything at the end of the for, it returns at the end of the for each, it returns the main value, sentinel value -1. To indicate that it didn't find anything. So you can actually have as many return statements as you want, but the important point that you have to understand is that when the function goes to execute a return statement, then that's it. The function is done. It returns a value and it terminates. And finally, I wanted to discuss this arrow function syntax, which has been introduced lately in JavaScript. It wasn't there at the start of all, at the origin of it all. And it's a syntax that I really love because it's a very compact and very intuitive, very elegant syntax to express, to create a function expression. In fact, as you see, the syntax is very similar to a function expression, only that we drop what is not strictly necessary. We drop the keyword function. Here are the inputs. Here are the character equal and greater than, and the greater than symbol. And then this is just the body of the function that you're already accustomed to. And since this syntax has been conceived for the maximum compactness, if the function is a one-liner, so it requires just one line, and the result of that line is what is the function wants to return, you actually can drop also the curly brackets and just say input arrow output, as you can see here. So this is a little reference that I leave with you for basic rules about arrow function syntax. As you see, very compact, intuitive syntax, input arrow output. The parentheses will contain the parameter, just like for normal functions, let's say. And if the function is a one-liner, you can drop the body. If the function is not a one-liner, you have to have the body and the return statement. And these guys are called also lambda expression in other languages like C# or Java. So don't be surprised if you see a concept that's basically the same thing with a different name. Well, guys, I hope this little presentation was useful to some of you, or maybe you were just curious to see how I could present this subject. I hope it was not too boring, and that this will help me improve so that I can become a better online teacher and finally be ready for a whole course together. Okay? Well, guys, talk to you soon then.